In this lesson, we are going to create a transformer pipeline from scratch. Let's understand how it works and see its capabilities. We already have an overview of it from our previous lesson, and now we'll go more in depth. Before starting, make sure you have set up the environment properly. The deployment should be in the active mode. We will have to add a JDBC stage library and install a JDBC driver before we begin building the pipeline. You will find the necessary instructions in the lab for this video. The engine has to be up and running. When building a transformer pipeline, you are going to follow the process described in our previous video, Understanding Transformer Pipelines, except that here you will select a blank pipeline. Let's see it in action. Select Create a Pipeline. Fill in the necessary fields and select Blank Pipeline. Select an authoring transformer. Keep the defaults. Once the preparation is completed, the platform will direct you to an empty canvas. Before starting to build a pipeline, we need to select a sample MySQL database our pipeline will be sourced from. Move over to your Academy Lab environment and enter MySQL. Note that you will be provided with the Linux commands used to access the database and tables in the relevant lab. Next, execute the command needed to view all the pre-built MySQL databases. These are all the databases we have. Let's pick one of them, Classic Models. After that, check out the tables it contains. In our demo, we are going to use employees, customers, and orders tables. Now it's time to go back to the cloud. We will be using 3 origin stages, one for each table. Select 3 JDBC tables from the drop-down menu. You may also use MySQL table, Postgres table, or alike, but make sure you have the relevant drivers installed beforehand. Once the origins are selected, move over to the first one. Rename it according to the table it will be sourced from. The first one will be called Employees. Next, set the connection path the way we did it in our Build a JDBC Pipeline video. The only difference is that this time we are going to use the Classic Models database. Then go to the Table tab and specify the relevant table. We are going to source from the Employees table. If necessary, you may also specify the columns to read. StreamSets is more intent-driven rather than schema-driven. If you don't specify the columns, all of them will be used, and in case in the future more columns are added, they will be automatically read as well. And later, you may get rid of the unnecessary fields with the help of Field Remover. Now configure the other 2 origins the same way, keeping in mind that they will be sourced from the Customers and Orders tables respectively. Set the customer's origin. Configure the order's origin the same way. Specify the columns you'll be using if necessary. All in all, these are the origins we are going to be working with. Suppose at the end, we want to obtain a pivot table or a flat table containing the customer's list together with the orders they made and the sales representatives who attended those customers. In other words, we will have to process the data from these three tables. In order to make it, we will use multiple join, field renamer, and field remover stages. At the end, we want to send the data to a file directory where we will be able to see it. Let's get started. First, select a join processor. This stage is able to join data coming from two sources, so we will have to use two of the join processors now and another one later in order to join the data coming from the three sources we have. The first processor is going to join the data on employees and customers. We're going to use the inner type, which returns records that have matching values in both inputs. We want to define the prefixes accordingly as well. Notice that the left one is considered the first input, and the right one is the second in the order. Next, specify the matching criteria. We can join by matching fields, but in this case, the fields from both of the tables should have the same name, and we will avoid using prefixes. And in this case, we would have to use an extra processor, field renamer, to rename the field name, or more effectively, would be to make use of the condition functionality. Here we can directly specify which fields we want to be joined irrespectively of their names. Now it's time to configure the second stage that will join the second and the third tables. Do it in the same way. This time the data on customers and orders is to be put together. Define the prefixes accordingly. And set the following condition. Both of our tables have this field. Now it's time to filter out the fields we don't need. Select two field removers. This stage allows you to either remove the undesired fields or keep the ones you need. We are going to apply the second option. In this section, specify the fields you want to be used. You may apply the bulk mode if there are several fields. Likewise, configure the other field remover. You can see that we have two data flows, but we want to get one table at the end. Let's merge them together with the help of another join processor. Once again, mind the order. The left one comes first and the right one second. Here we need to specify two conditions. The first one will unify the data on sales representatives coming from the employees and customers tables, whilst the second one will put together the customer number fields that are received from the customers and orders tables accordingly. All in all, you have gathered all the information needed, but there are some repetitive fields containing excessive information, and again the field remover has you covered here. This time, an optimal way will be to specify the fields we want to get rid of. These are customer number and sales representative employee number. As of now, our soon-to-be flat table looks almost perfect. Yet, there is a field carrying a different prefix. No problem. Take advantage of the field renamer. Make the order number field look similar to the other fields by adding the order's prefix. Do the same for the order date field. After all, the last question that remains is where we will store our data. Pick a file directory. Give it a meaningful name. Locate it somewhere you can easily access. Don't forget to define the write mode here and the data format in the section with the same name. Run the preview to check the results. And lastly, reset origin and start the pipeline. It's a batch processing pipeline, so once the data flow is completed, it will automatically stop. Now let's see the results in the real-time summary section. The origins have only the output, whilst the processors have both the input and the output records. Lastly, the storage directory also has the input and the output records. Now let's check the resulting output. Go up, click on the Authoring Transformer button, and copy the engine number until the colon sign. Move over to the Academy Lab environment. Exit MySQL and enter the container you have been using. You can see the file that has been created. To view it, proceed with the following command. And there you have it, all the necessary data collected in one place. Be sure to check the lab instructions if you want to learn the commands used in this video. These are the field names, and this is the data we have gathered and put into one table. Here is the final pipeline that uses multiple origins, joins, removes, and renames the data fields, creating a flat table as an output. Deploy StreamSets Transformer. Create a draft pipeline using our instructions, run it, and see the results for yourself. Thanks for watching, and we will see you in the next video.